What's happening, dogs? Mr. Allen here. We are about to graph the exponential function f of x equals 2 to the x and f inverse of x, which means we're going to have to find that inverse. Woo! That's going to be fun. And don't forget, we got to label the two graphs on this thing so we know which one is which. Let's start with graphing f of x equals 2 to the x. So some points that we could plug in. We got to pick and choose. I'm going to go with this. I'm going to go with a -1. I'm going to go with a 0, 1, and let's even go with 2. I'm going to go 4 points right now. It's kind of crazy. All right, so if I plug in -1, 2 to the negative first is going to be 1/2, so 1 over 2. 2 to the 0 power is just going to give me 1. 2 to the first is going to give me 2, and then 2 to the second is going to give me 4. And when I plot these two, I've got -1, 1/2, which is going to be right here. I've got 0, 1, so 0, 1 is going to be right here. And then I got 1, 2, and then I have 2, 4. All right, there we go. So connect the dots. Boom. Beautiful, man. Beautiful. All right, it gets infinitely closer to that x-axis, but never touches it or crosses it. So if we'd like, we can even jot down our nice little asymptote here, which hopefully we can see. All right, and that is our y equals 0 asymptote. And we know that this guy right here in green is f of x. Excellent. All right, let's switch colors for the other one. Now we're going to find our inverse. How do we find the inverse? Let's see here. Well, one, we could actually hold up. Let's pump the brakes. Let's get some thoughts here. Do we even need to find our inverse? Because I know for my inverse, I just switch my x and y's, right? So here I could just do this. I can go 1/2, -1, 1, 0, 2, 1, and 4, 2. I know at the start I said we got to find our inverse, our function, but I don't even need to, right? It just asked me to graph it and label it. So now what I'm going to do is I'm going to have 1/2, so 1/2, -1, so it's going to be right here. I've got 1, 0, which is going to be right here. I've got 2, 1, and I've got 4, 2. I can connect these dots. Whoop. Beautiful. And let's think here. If my horizontal asymptote was y equals 0, all my x's and y's switched. Now I'm going to have a vertical asymptote of x equals 0. So this is going to be x equals 0 for the vertical asymptote. And I got to label this guy as f inverse of x. Now, let's just say for fun, let's say they ask you, they said like, hey, what is the function, right? Let's say that, like f inverse of x, it has a little blank, right? It's like, give me the equation, bro. Let's see how we'd find that equation, right? Because we could ask for that on a test. We could. All right. So I'm going to first write this as y equals 2 to the x. Then I'm going to swap my x and my y's. Oops. That should be 2 to the y. Oh, my goodness. 2 to the y. And now I can resolve this thing for y, just like I do any other inverse, right? Swap my x and y's, resolve for y. But how do I solve for y here? How do I get that y out the exponent? I got to put it into log form. So I'm going to do so by looping and a swooping. All right, now some people like to write this as 2 to the y equals x before they get to looping and swooping because you want to go whoop. There we go. We're going to have log base 2 of x. So start to the 2 of x equals y. So that means I'm going to have f inverse of x being log base 2 of x. You could have loop and swooped from the previous form. It would just be going back the other way, right? Same thing. Log base 2 of x equals y. That's it, and that's dope. Well, there we go. Now we got our equation. We got our graphs. Let's talk a little like domain and range, okay? I'm not going to write this stuff down, but we'll at least talk about it. So my domain for this green guy here, my original, right? Domain is everything to the left, everything to the right, all real numbers. My range, always greater than 0, right? It's always above that x-axis. Well, man, I'm mixing things up. All right. Now for my domain and range of my pink one here, right, the f inverse of x, that's going to swap, right? My domain is greater than 0 because it's got that asymptote there. My range is all real numbers. It keeps going down. It keeps going up. Cool? That's pretty dope. My intercepts, I've got 0, 1 for my original. My exponential is 0, 1 for my y-intercept. My inverse doesn't have a y-intercept, but it does have an x-intercept, 1, 0. Cool. That's some good stuff, some dope stuff about these graphs. I love it. How about this? Intervals of increasing and decreasing. This f of x function, it's always increasing. So from -infinity to infinity, this bad boy is increasing. Now, what about the inverse? It doesn't exist over here, right? So it would be from 0 to infinity. From 0 to infinity, parentheses, it'd be increasing. All right, cool, man. That's dope. That's awesome. I hope you guys enjoyed it. This nice little graph here. We even found the inverse, even though we didn't have to if we were just asked to graph it. Got it labeled. That's dope. Deuces.